So hello students. Because of some interruptions in the network, so we have disconnected. So just now we came live. So in the last session, we have finding the solutions for these equations. Okay, so we will continue from here. So here it is the given solve the following equations by using the Cramer's rule. So we have written the equations by uh, in the determinant form. Okay, here we are solving the system of the linear equations by using the determinant, or it is also called the Cramer's rule. So we have written the all the coefficient in the terms of the lambda, and lambda x the x coefficient will be replaced with the that constant value. Delta y, we are solving for the delta y. So let's see. So we are expanding along the second column. So second column it will be plus 52 plus 52, so it will be minus 1 minus 2 and 0. This will be the minus 16 minus 16 minus 16 into 9, how much? 16 into 9 and 54, 54 9 5 44, so it will be 140 144, and it will be the minus 3, 53 into minus 3, 6 and 156, so its value will become minus 12. And right, yeah, delta y we are getting minus 12. Okay, now we will are going to find the delta z. Delta z, the c1 c2 will be replaces with the constant value, that is the, and the remaining will be the same, so 9 52 and 0. So again we are expanding along the third column. So 9 into, because it has the 0, so it will be easy to expand along the this column. So 9 into uh, twice minus 10 and minus 52, it's having the sign negative. 1 minus 2, 1 minus 2, so it will be minus 8 minus 72 and minus 1, minus 1 plus 1 52, so it will be 20, minus 20. So from here we will find the x value. X value, we know that it is the delta x upon delta. We have calculated delta x is equal to minus 4 and delta is equal to minus 4. So minus 4 upon minus 4, it will, x value will be 1. Y value will be the delta y upon delta. Delta y we have calculated minus 12 upon delta, and delta is the minus 4, its value will be 3, and the z will be calculated by the delta z upon delta. So delta z we have calculated minus 20 upon delta minus 4, it will be minus 5. So same equations we will solve by using the matrices also. Okay, so first of all we will see the theory for the how to solve the system of the linear equations by using the solutions of system of linear equations. System of linear equations by using matrix method. Matrix methods. So again we are writing the system of the linear equations. A1x plus b1y plus c1z is equal to d1. Okay, now a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. So here we can see the system of the linear equations. The three system of the equations are given. So here we will write the equations in the form of the matrix. So here we are taking the we will writing in the matrix form the coefficient of the xyz. So the coefficient of xyz, it is a1 a2 a3, here b1 b2 b3, and here c1 c2 c3. Okay, and here we are writing the x represents the three values, that is the x, y, and z in the matrix form, and we are writing the b terms, the constant term, that is the d1 d2 d3. So if we multiply the ax, it will be equal to b. So we will write the system of the linear equations can be written by system of linear equations can be written in the form of ax is equal to b. Ax is equal to b. Okay, so from here we can say that we will multiply by both side. Multiply both side by A inverse. A inverse, so if we are multiplying both side by the A inverse into x, A inverse into B. So A inverse into A, it will become I, identity matrix, and the right side will be the A inverse. We know the formula for the A inverse, that is the 1 upon determinant of A into adjoint of A into B into B. This is the relations. Okay, so we will write the x value, it is equal to 1 by determinant of A and adjoint of A dot B. So the system of linear equations, it will depends on the value of the adjoint A dot B. Okay, so same way we will see the conditions, in which conditions it has the unique solutions or infinitely solutions. Okay, so when the case first, when a is equal to not equal to 0, not equal to 0, so it will have the unique solutions. So in the unique solutions, it is also called the consistent solutions. The system of the linear equations are consistent. Okay, and x y z have the unique value, so it is also consistent, and it is also called trivial solutions. Now the second case, if the determinant of a is equal to 0, so there will be the two cases in this one. If adjoint of a dot b will also be equal, in that case it has the infinite number of solutions. Infinite number of solutions. So it is also called the consistent solutions. Consistent, and it is also called the non-trivial, because there will be the no specific value of the x y z, so it is called non-trivial solutions. And in the last case, it is the if determinant of a is equal to 0 and adjoint of a dot b is not equal to 0. In that case, it has the system of linear equations has the no solutions. So in no solutions, it is called as the system of the linear equations are inconsistent, and about these solutions, it has the non-trivial solutions. So in the same way, if the questions will be given for find any lambda value for non-trivial solutions. So for non-trivial solutions, we will take the determinant of a is equal to 0. Okay, so the same equations we are going to solve by using the matrix method. Okay, so here we can write the determinant of a, we have already calculated by writing its coefficient of ABC, that is the delta we have already calculated, that is the -4. So here we will write here determinant of a is equal to -4, so it is not equal to 0. So in that case, it has the unique solutions. So here we are going to find the system of the linear equations by using the matrix method. So system of linear equations can be written by system of linear equations can be written as ax. Ax is equal to b. So x, we have just now we have seen it is the A inverse dot b. So A inverse, we will write A inverse, it can be written as 1 by determinant of A into adjoint of A dot b. So here we have calculated the determinant of A. We have to find firstly the adjoint of A. So how to find the adjoint of A? This is the Cij of transpose. Transpose of its Cij. So firstly we will see the A value. A value we have seen. A value as, what are the A values? 1 1 triple 1 1 1, then 257 2 1 minus 1. These are the matrix of A. Okay, so what will be the its adjoint? So for finding the adjoints, we will take the its Cij of A. Okay, so one for this one, the Cij will be the -5 minus 7 minus 12. For this one, minus of minus 2 minus 14 minus 16 minus positive. This one 2 minus 10 minus 8. For this one, minus 1 minus 1 minus 2 minus plus 2, and for this one positive. So minus 1 minus 2 minus 3. For this one, negative. So 1 minus 2 minus 1 minus 1 minus plus 1. For this one, positive. 7 minus 5 2. For this one, negative. So 7 minus 2 5 minus 5. Okay, and for this one, it will be the 5 minus 2 3. So these are the Cij. So what will be the Cij of transpose? Cij of transpose, its value I am writing here. Rows will be converted into column, and column will be converted into rows. So minus 12, 16, minus 8, 2, minus 3, 1, 2, minus 5, 3. These are the values. So what will be the adjoint of A dot B? So the same value, minus 12, 2, 2, 16, minus 3, minus 5, minus 8, 1, and 3 will be multiplied with the B matrix. B matrix, it is given, that is the 9, 52, and 0. So the rows will be multiplied to the column. First row will be the multiplied with the first column. So minus 108 plus 4 and 10. Then 16 into 9, 144, and minus 156, and from here minus 72 and plus 52 and plus 0. In all, it will be plus 0. So this one will become minus 108, minus 4, this one minus 12, and this one minus 20. So the x value we have seen, that is the x value x value will be the 1 by determinant of a into adjoint of a dot b. So we will write the determinant of a we will have calculated, that is the -4. Determinant of a is equal to -4, and adjoint of a into b will be the -4, -12, and -20. So -4 will be multiplied to x value. X value, it is the value of x, y, and z. X, y, z. So -4 will be divided by each of the terms. So its value will be 1, 3, and 5. So from here we can write x is equal to 1, y is equal to 3, and z is equal to 5. We have say get the same of the value 1, 3, 5. X, y, z, we are getting the same value, that is the 1, 3, 5. So the system of the linear equations, it can be solved by using the determinant, that is called Cramer's rule, and by using the matrix method. Okay, so in the questions, mainly in the CBSE questions, they will, in the board type of the questions, they can ask the questions about the solved by the system of the linear equations by Cramer's rule. So in which we have to apply the determinant method. If it is not given in the questions solved by the system of the linear equations, we are independent to solve by using the any of the methods. Either we can solve it by the Cramer's rule or determinant value, or by the matrix method. So today we have seen the very important concepts to how to solve the system of 3 linear equations in 3 variables. Okay, so this type of the questions commonly will be asked in the IIT JEE examinations as well as in the board examinations, and the mainly questions will be asked for the non-trivial solutions. So for non-trivial solutions, we make the delta will be equal to 0. Delta will be the coefficient of the xyz in the determinant form. So ओके, सो आज की क्लास हो गई, तो मिलते हैं अगले क्लास में, कल की क्लास में एक नए टॉपिक के साथ। तो हम आप हमसे जुड़े रहिए और ज़्यादा से ज़्यादा हमारे वीडियो को शेयर कीजिए, ताकि ज़्यादा से ज़्यादा लोगों तो स्टूडेंट्स तक हमारी सिस्टम पहुंच सके। तो मिलते हैं कल की वीडियो में नए चैप्टर के साथ। तब तक के लिए गुड नाइट, शुभ रात्रि, बाय।